Making bonds is an endothermic process, and making bonds is an exothermic process. To explain this, I'll use a bit of an analogy that I made, and I feel like this is a really easy way to understand why this happens with a nice simple analogy. For GCSE Chemistry, and afterwards we'll go through some past paper questions so that you can actually consolidate your learning. So, why is breaking bonds endothermic? So when you break bonds, right, the different particles that you have, for example, you could have hydrogen and a chlorine bond, right? These bonds are getting broken apart. So hydrogen goes its separate ways and chlorine goes its separate ways. So the bonds are being broken apart, right? Why is this endothermic? You would imagine that if your bonds are breaking, then it's going to release energy, right? But why does it take in energy when you're breaking apart the bonds? It kind of goes against your common logic, right? So that's why I came up with a really simple analogy so that you can easily remember this for your exams. So when bonds are being made, right, we're going to start with making bonds first. And likewise, when you think of making bonds, you would think that that is an endothermic process, right? Because these bonds are being created, so you're going to need energy to do that. Why is it an endothermic? Why is it an exothermic process? So it just goes opposite your logic. So this analogy makes it really simple. So when bonds are created, right, the different particles are joining together. So we have like a hydrogen and chlorine, right? These are joining together when the bonds are being created, right? So this means you can imagine that hydrogen has its own heat source. So hydrogen is like a bit of a lamp. Like it's like humans, right? Hydrogen is a human and chlorine is another human that both release heat. When we're cold in winter, we can hug and share our heat to keep both of us warm. So when hydrogen and chlorine bond together, they can share the heat together to keep them both warm together, right? They don't have to separately just warm themselves up. They can make one big heat source and share it together. That's why it's an exothermic process. Because when bonds are made, they share their resources together. So it's exothermic because they're sharing it. By the way, exothermic is when you release heat, release energy. So you can now know that breaking bonds, they used to share their energy like this together. But now this bond has been broken. There is no bond between them anymore. So hydrogen has to make its own heat source, and chlorine also has to make its own heat source. That means they're both going to be really cold, so they're going to need additional sources of heat. That's why it's an endothermic process, because they take in heat from their surroundings, heat and energy from their surroundings, to keep each of themselves warm, because now they don't have each other to rely on. That's a really simple way. Breaking bonds, endothermic. Making bonds, exothermic. It kind of goes opposite logic, but if you think about it like this, it's kind of an easy way to remember that. Then let's look at some examples that you might need to answer for your GCSE paper. Okay, this is a reaction profile diagram. Okay, energy profile. So, which of the energy changes, A, B, or C, represents the activation energy for the reaction? So you can obviously instantly know that this is going to be an exothermic reaction because the products have less energy than the reactants, right? So that's releasing energy. So the reactants, the activation energy, to the energy needed to start off the reaction, that's going to be A, obviously. It's obviously not going to be C because that's just the energy, total energy being released. And B is just the energy being released minus the activation energy. So A will be the activation energy. And the amount of energy given out during the reaction, that's going to have to be B. I'll explain this right now. So why is it B instead of C? Well, C is the total energy given out during the reaction. You are correct with that. But it also includes the reactants, which is the energy taken in from, say, the Bunsen burner to start off the reaction. That's not the reaction given off from the reaction itself. B is the only energy source that's actually being released from just the reaction, not the activation energy being re-released back. So it has to be B. Now explain in terms of bonds breaking and bonds making why this reaction gives out energy. Well, this is the concept we've been thinking about right now. The reactants, the bonds in the reactants need to be broken. The bonds in the reactants need to be broken. Okay, you know what? I apologize for the bad handwriting. Let's just type this out instead. I feel like that'll be better for everyone. It's easier to see. So let me get a keyboard. And change my color. Just bear with me just a second. Yes. Oops. Alright, that should do it. Yeah. So, the bonds in the... Okay, let's raise this up a lot more. You know, I should have done this in advance. Apologies for that. The bonds in the reactants need to be broken apart to form the products, right? You need to first break the bonds in order to form the new products, right? When bonds break, when bonds break, it takes in energy. And the most common example is going to be heat, hence being an endothermic reaction. Then the bonds need to be made again to form the products. This requires energy to be released, hence being an exothermic reaction. And as the reactants have as the products have less energy than the reactants, it is an exothermic reaction, meaning it gives out energy. That's basically a model answer for this 3-mark question. And you'll be able to get all the marks for this because 1, you talked about the bonds need to be broken apart to form the products. When the bonds break, it takes in energy, being an endothermic reaction. That explains the first section, why this reaction gives out energy. Then the bonds need to be made again to form the products. Energy is released. As the products have less energy than the reactants, it is an exothermic reaction, meaning it gives out energy. 3 marks right there. And that's just the common answer, A and B. I hope this explains the concept of why bond breaking is an endothermic reaction and why bond making is an exothermic reaction. Kind of the opposite of what you might think logically. Thanks for watching this one.